Good evening, all. I welcome you all to the 14th session of our journey entitled Geography Through Maps. My name is Pritesh Maturkar. I welcome you all to this exemplary journey. I welcome you all to this very astonishing endeavor wherein you and I will go on a world tour where I, as your able tour guide, mentor, philosopher, friend, will be there with you all for understanding the tidbits, for understanding the physiography of Earth using the most potent tool in geography's discipline, that is maps. So, using maps, we will try to understand how the Earth is, how the different geophysical systems on Earth function, and how do they impact the local society, how do they impact your and my interaction with the world. So that is the greater kind of initiative of these sessions. But speaking academically wise, those of you who are watching me for the first time today, or those of you who are continuing watching these sessions, so academic wise, I intend to cover roughly 10 to 20 marks in your prelims and roughly 100 to 200 marks in your mains. And if essay comes in your purview, guys, we will ramp it up to around 300 to 400 marks too. So guys, these sessions will have heavy utilitarian value with regards to prelims and mains both. And using these sessions, you will be roughly able to cover 50 to 60% of your mains GS discourse of geography, of environment, as well as of ecology. And using the basis of this discourse, you can even learn some of the advanced level concepts too. So that will be my greater zeal with you all, that I make you aware of the entire curriculum of the civil services examination with regards to geography, environment, and ecology. And in the end, you and me will come out in knowing the world, in analyzing the world, and in also understanding the current issues that the world is pegging. So through these lectures, I also intend to cover majority of the current affairs with you all. And using this current affairs, we will again try to analyze how the world is interconnected. So I welcome you all formally on the behalf of StudyIQ IAS English team. Let's begin this journey. So whenever I begin this journey, the typical flow of work is like this. So in the first 5 to 10 minutes, I quickly revise what I did in the previous sessions. Then as we move ahead, I introduce you to new topics. As I introduce you to new topics, I explain you the topics conceptually. We try to have utmost clarity of those topics. And once we have clarified those topics, we try to use it on a practical scale. We try to use it on the atlas scale. But considering that you require some prerequisites for understanding the world atlas, so some of the sessions for now will be dedicated to understanding the basic tidbits of Earth's physiography. So day before yesterday, I finished up the tidbits with regards to climatology. Yesterday we started discussing the land surface of Earth. So today onwards, for at least 5 to 6 sessions, we'll be focusing primarily on the Earth's land surface. We will try to analyze as to what is happening, and then once we are done with the Earth's land surface, I will slowly take you on the oceans. We will sail through the waters of the Earth, and then finally, when I feel that yes, all of the spheres of Earth are now properly done, we will then start analyzing the world atlas in detail, wherein you and me will analyze our biosphere, which is the amalgamation of all these three spheres where you and I interact with the environment. Okay, so let's start today's journey. As promised, I'm starting every day of this journey via beautiful diagram, via beautiful image. So the image which you are seeing in the back of me, okay, this image has taken, I don't know how much amount of brain activity, I don't know how much amount of money, I don't know how much amount of zeal, but the image which you are seeing on the board today, this image is basically, you can say, the greatest image ever produced up till now. Why? Because this is the image of the distant galaxy clusters captured by the James Webb telescope. Yesterday I did introduce you to the origin of universe, the Big Bang theory. So when we launched the most costliest experiment in the space, the James Webb telescope up till now, so James Webb telescope has captured this beautiful image of distant stars and clusters. If you see in this image, the blue dots you are seeing, these are very distant galaxies, and The bottom of this image, you are seeing the giant amorphous clouds from where you are having small clusters originating, from where you are having distant galaxies originating. So the bright clusters you are seeing are fairly new galaxies. Fairly means they are still billions of years old, but the distant clusters you are seeing like this, okay, in the dark blue or in the dark black, these clusters are very old. They are more than 10 billion years old. So for the first time, guys, what you are seeing on the board is basically our origin. So please treat this image as the original image from where you and from where our universe has born. So basically this is the true God of the world, or this is the true cosmos, the true almighty from where everything has spawned up. And you and me are living in extraordinary times, that with our bare eyes, that with our bare vision, we are able to see all this, we are able to process all this, and that we are able to understand how we have originated. And we are the only species on earth as of now who can do this. And we don't know whether we will find a super intelligent species even more than us. But for now, dare I say, in the universe, we are the most supremely intelligent species who can say that yes, we have now found a source or trace of our origin. So this image is a very beautiful image. This image I have downloaded from the NASA's website. If you wish, you can save this as your wallpaper and be it your as a source of inspiration, that yes, now see where we have gone. Okay, so let's begin our lecture for today. Before I begin, again, I would like to quickly introduce myself to those of you who are watching me for the first time. My name is Pritesh Maturkar. I will be your primary faculty for handling the Geography GS discourse. So the discourse entitled Geography Through Maps, the curriculum of which we are today having 14th lecture. Those of you who are watching me, or those of you who will watch me on a later time as per their convenience, so treat this curriculum as the basis of your mains preparation. Treat this curriculum as the basic preparation for you all to have the proper test bed of civil services examination. And with regards to civil services examination, the relevant current affairs, the relevant tidbits, the relevant PDFs, which I feel is important. Okay, guys, I'm not a faculty which will cringe in as much information as possible. No, that's not my job. So I try to give you such content which is having absolute validity, not relative validity. Okay, I'm re-editing myself. I will give you a content which will have absolute validity, not relative validity. What do you mean by absolute validity? That for sure this content is bound to resonate in your preparation and your mains examination as well as your prelims. So for getting such content, you can reach out to me on a Telegram channel called as Geography by Pritesh Maturkar. For joining this channel, you can just do a global search on Telegram at Geography by Pritesh. If you just search this in your search bar on Telegram, you will be able to see this channel, where on a daily basis or every fortnightly basis, in every 14 days, I try to post roughly 5 to 6 links or 5 to 6 PDFs, nothing more than that, which will have absolute validity in your preparation. Okay, so please join this channel. It's for your better good, so that you have a working understanding of what is happening on earth, and it will ultimately translate into you getting good marks and getting, of course, good all India rank. That is what we all want from you all. Okay, so let's move ahead with today's discussion. So yesterday I did introduce you to the origin of universe. Yesterday we did discuss the Big Bang theory as propagated by George Lemaitre. So if I want to quickly summarize what we did yesterday. So yesterday I began with the understanding of the Earth's surface, but for understanding the Earth's surface, first we should all know that how everything began. So the beginning of everything is attributed to a theory called as Big Bang theory. The universe began approximately 13.6, 13.5 to 15 billion years ago. So it all began from a singularity, from a singular dimensionless point having infinite mass, infinite gravity. From there, you had sudden cosmic inflation. You had sudden cosmic expansion. This cosmic inflation or expansion threw out or spilled out cosmic dust throughout cosmic bodies, from which all this dust, all these bodies, they started coalescing to form the present day universe that we have. So is the universe still expanding? Yes, of course, the universe is still expanding. Is the universe static or dynamic? No, universe is a dynamic entity. Okay. With regards to Earth per se, the origin of Earth is attributed to roughly 3.8 to 4.5 billion years ago. That's the origin of Earth. And with regards to origin of Earth per se, the most acceptable theory is the nebular accretion process. What do you mean by nebular accretion process, guys? Nebular accretion process basically means that Earth was initially a very giant hot cloud, a very giant hot nebula of condensing gases like hydrogen and helium. As this nebula started to rotate around a disk shape or around in a spherical shape, as it started to condense, so as it started to condense, because of that you had the heaviest of elements condensing in the Earth's interior, and then as you move out of the Earth's interior you have lighter elements arranged in concentric circles. So the heaviest elements you will find in the Earth's interior because of the accretion, and as you move out from the interior towards the surface, the elements, they vary in their density. So in the interiors you will find heaviest of elements, outside you will find lightest of elements, and of course the atmosphere will have again the lightest of elements. The earliest atmosphere was rich in gases like hydrogen and helium, which today all escaped. Why? Because hydrogen and helium, they are the two basic blocks of the periodic table from where everything begins. So as more and more substances coalesced, you had the formation of the most primitive Earth, and the primitive Earth was nothing what we have today. So I ended your discussion over here. Good evening, Utnang. I hope these sessions are enlightening to you. So I will start my discussion from today, from here onwards, that yes, the Earth that we have today was nothing what the Earth was in the before ages or the primitive ages. So let us begin with the understanding of the primitive structure of Earth. How was the Earth's crust? Okay, how did it evolve through time, and what were the different mountain ranges that originated through different geological time scales? So again, today's session will be extremely interesting. So let's begin our journey. Okay. Good evening, Rahul. I am also a fan of you. Don't worry. Like you are a fan of StudyIQ, so I am also a fan of you. We all will grow together. We all will achieve success together. Okay. So jokes aside, let's begin our discussion. So I'm beginning with the discussion of the primitive nature of Earth. Okay. So if I'm considering the primitive Earth, okay. So primitive Earth is basically which kind of Earth? The Earth which is still condensing. The Earth which is still condensing. Okay. As the Earth is condensing, you have the formation of the world's first crust. You have the formation of the world's first crust, Okay, so if I'm drawing it diagrammatically, so if the Earth is condensing like this, so Earth is slowly turning, is getting into its spherical shape. Inside you have the heaviest of elements. Outside, as you move out, the elements are varying in terms of density. So inside, the core of Earth will have the heaviest of elements, and outside, as you move outside, you will have lighter elements. Okay, these lighter elements will coalesce to form some of the world's most primitive crust. But the crust that we have today, the outermost layer of Earth that we have today, was nothing as it was before. The world's primitive crust was very thin. It was very thin. It was extremely fragile. Okay, it was extremely fragile. Why, you will ask me, sir, why the Earth's first crust was very thin? Why it was extremely fragile? So you can consider the formation of the first crust in comparison with the kettle of a boiling milk. So if you are boiling the milk, if you have boiled the milk at around 100 degrees Celsius, and once the milk has frothed, now the milk is settling. So as the milk is settling in the kettle, above the milk you will have a light layer of cream. As the milk cools, a light layer of cream comes over the top of the milk. So you can consider the first crust of the earth like the cream layer which comes atop in a kettle of boiling milk. So if you see that layer, is that layer a perfect layer? No, it has got ridges, it has got corrugates. And is that layer very solid? Can you not put your finger inside the layer from above to below? Yes, you can very easily break the layer. So it was the same thing with the earth's crust. As the earth was cooling, as the earth was coalescing, you have the world's primitive crust, very thin crust, very fragile crust. Why? Because the earth was still cooling. Rather, the earth today is still cooling. Today also the earth has not cooled down completely. Today also the earth is having its own internal heat source, which I discussed yesterday. So you have earth's internal heat source in the form of that the nebular accretion process is still going on, and you do have radioactive elements inside the earth like uranium, like thorium, which undergo radioactive disintegration, and because of which we have the earth's residual heat today. Okay, so the first crust of the earth was something like that, very thin, very fragile. Basically, it was the beginning of volcanism on earth. As the elements coalesced, as you had the formation of volcanic magma, so magma started to come out. You had the pouring of lava. The lava pouring gave to the formation of the first crust. But again, I'm repeating, the first crust was very thin, it was very fragile, and it was bombarded by what? It was bombarded by celestial bodies. It was bombarded by celestial bodies. Why? Because the Earth's atmosphere was not fully developed. Okay, so I'm taking you back to approximately 3.8, 3.7, 3.6, 3.5 billion years ago. Earth's atmosphere is not fully developed. The Earth's atmosphere is not able to stop the outside meteoroids from reaching the Earth. Today, what happens if any meteorite reaches the Earth's atmosphere? It burns down because of the frictional forces. But the primitive Earth didn't have the atmosphere to protect itself. So, the Earth's crust was also heavily bombarded. Now, as the Earth's crust started to form, as you had this very thin, fragile crust forming, and as Earth was a dynamic entity, today also Earth is dynamic entity, as these pieces of crust, they started to collide, as you had volcanic movements on earth, as you had movements along this crust, you have formation of the world's first mountains. So now let us take our discussion even further. Let us now start using maps. For the first time, you will be pretty happy in this session that today I am finally introducing you to one of the most detailed aspects of mountain ranges we have discussed up till now. So as this crust starts to form, as this crust pieces starts to dismantle, they start to collide, you have the formation of the first mountains and the first supercontinents. So as this crust coalesced, as this crust formed, you had the formation of the world's first supercontinent. The formation of the world's first supercontinent, where all the crust of earth was joined together. You basically practically had very few oceanic landmass. So the world's first supercontinent, it is called as Rodinia. Okay, I'm reiterating, the world's first supercontinent, when this crust formed, a very thin fragile crust, the world's first supercontinent, the world's first supercontinent, the world's first supercontinent is called as Rodinia. It is called as Rodinia. Okay, so Rodinia was the world's first supercontinent, and the crust which you had in Rodinia, the crust was very thin, it was very fragile, and as it was very thin and as it was very fragile, it broke up easily. It broke up easily. Okay, it broke up easily, and as it broke up, different segments started to collide. So you had this very thin primitive crust like this, and as it broke, individual pieces started to collide. Okay, small fragments, they started to do what? Small fragments, they started to collide. Small fragments, they started to collide, forming 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 the first mountain ranges of Earth, forming the first mountain ranges of Earth. Okay. Anybody who is watching online, feel free to comment which are the world's first super mountain ranges, which are the world's first mountains, rather dare I say, which are the world's oldest mountains. Uttang Pangaea is not Rodinia. Pangaea comes after Rodinia. Okay. Rodinia basically breaks up the individual pieces of continents, the individual pieces of landmass, they start to collide, small fragments, and as these pieces collide, as these pieces start to interact, you have upliftment of mountains. Can anybody answer me which are the world's first mountains, or dare I say the world's oldest mountains? Okay. So, the world's oldest mountains, the world's first true mountains, the world's first true mountains, or the world's first orogens, the world's first true mountains or orogens, you will be shocked to hear this, guys. They are in India. Okay. The world's most oldest mountains, the world's first true origins, when they uplifted, they were having elevation of more than 13 kilometers. And the world's first true mountains and orogens are the Eastern Ghats. Are the Eastern Ghats. So Eastern Ghats were formed when Rodinia broke up. When Rodinia broke up. When Rodinia broke up. And when Eastern Ghats were formed, you also have upliftment of some of the other older mountain ranges. And again, you will be shocked to hear this. The other older mountain ranges which date back to these times. Okay. I'm talking about which time, guys? I'm talking roughly 3.5 billion years to 2.5 billion years ago. Billion years ago. So this is the time scale that I am talking about. So Eastern Ghats, their age is roughly 2.9, 3.1 billion years ago. So in the same time scale, other mountain ranges did uplift, and all of them are again in India. So you have upliftment of Satpuras, you have upliftment of Satpuras, you have upliftment of Vindhyas. You have upliftment of Vindhyas. Both of them have their orogeny approximately 2.8 billion years ago. Both of them have their orogeny approximately 2.8 billion years ago. So you should be proud about this, guys, that you are sitting in a landmass, you are a citizen of such a landmass which has the world's oldest mountain ranges, which has the world's first true orogens. So any one of you, if you are now going to Tamil Nadu, if you are now going to Andhra Pradesh, if you are now going to Odisha, or you are going to Madhya Pradesh, you are going to Rajasthan, and if you pick up the soil, if you pick up the rocks in this region, basically you are holding a rock which has seen the formation of Earth. Sadly, in India, we don't have geological national parks. Late of last year only, we had the induction of the first geological national parks of India. But I guess it is our duty, it is your duty now to educate the society that India's landmass is one of the oldest landmass on Earth. It's a great thing of pride, guys. If you go to Tamil Nadu, if you go to Maharashtra, if you go to Madhya Pradesh, the rock which you will pick up, it is one of the oldest rocks of the earth. That rock has basically seen the formation of earth. What a beautiful thing like this. Okay. So I guess it's my humble duty to educate you, and now it's your humble duty to propagate this in the world too, that we should take intense pride in our motherland. The land which you are sitting on is one of the oldest cratons of the world. I have not yet introduced the word craton. Slowly I will introduce the word. Okay. So you have Vindhyas and Satpuras. So this is when you have the formation of Rodinia, and as Rodinia breaks up, you have the pieces colliding, individual pieces colliding, and then you have upliftment of Eastern Ghats, you have upliftment of Vindhyas and Satpuras in India. So again, I'm reiterating, the world's primitive crust was nothing what we have today. The world's primitive crust was very thin, very fragile. You can equate it with a layer of cream which comes atop in a kettle of boiling milk pot, where that layer has got corrugates, that layer has got ridges, and that layer, it can expand, it can contract, and it is very fragile. If you just put a finger on it, it will break apart. So that was the thing. Now, after this, what happened? You had this individual pieces again colliding. Okay, you had this individual pieces again colliding, and after Vindhyas and Satpuras, you again have upliftment of some of the other mountain ranges of the world. So after this, you have three distinct mountain building phases. So some of the three mountain building phases I am now discussing with you. I won't be discussing the entire mountain ranges with you all today itself. We'll do this when we'll do the detailed discussion of Atlas. But after this, you have two distinct mountain building phases, wherein you have upliftment of some of the mountain ranges in the world, and then we will take the help of the world atlas to showcase those mountain ranges. So after Rodinia breaks up, okay, you have upliftment of Eastern Ghats, you have upliftment of the Satpuras and Vindhyas. Breaks up means what? Like when it's not that Rodinia is completely breaking up. Okay, so as the individual pieces collide, you do have upliftment, and side by side the breaking of Rodinia is still continuing. Okay, as these individual pieces are again colliding, you have the first mountain building phase of the world, that is called as Caledonian mountain building phase. Okay. Yes, Vishal, that we now have one more layer in the earth. I will discuss it in our ending part when we will have the discussions with regards to current affairs too. No, we shouldn't consider one more inner core. No, inner core is intact. Inside the inner core, you have true inner core. Please understand this. Vishal over here is asking that, sir, it is in the news that we now have a new layer of earth. So should we consider it as one more inner core? No. Basically, inner core is the same. Now, inside the inner core, you have true inner core. True inner core means what? That the density over there is even more extreme. The density of over there is the most extreme that you have on earth, and because of that density, because of that consistency, that new layer is termed as the true inner core. It is not named differently. Okay, up till now the layer has not yet been named differently. Had it been the name differently, let's say if the name of the layer is somewhat different with regards to inner core, then we will say that we have one more layer named as one more inner core. No, it is not one more inner core. It is basically the same inner core, but inside the inner core, now you have one true inner core, which confirms or which does justice to the name inner core. Why? Because the density is the most extreme, upwards of 13.7. So upwards of 13.7 density you have in the true inner core. So don't get confused at all. Okay, so let us now come back. So I'm introducing you all to the first mountain building phase of the world. As this Rodinia breaks up, as the pieces starts to collide, and you have upliftment of the mountain ranges. Okay. So the first mountain building phase that you have in the world, it is called as Caledonian mountain building phase. Mountain building. Caledonian mountain building phase. And you have another phase called as Hercynian mountain building phase. Hercynian mountain building. Hercynian mountain building phase. Please remember the name of these two phases, because we will be needing them when we will do the atlas in detail. So Caledonian mountains and Hercynian mountains. Okay, so if I try to paint a picture of some of the Caledonian mountains and some of the Hercynian mountains, so let us now open up the world's Pandora box and let us open up the world atlas for you all, where I'm discussing some of the mountain ranges of the world that we have today. Today I'm just showcasing you them on the atlas. Please don't get confused. We will do all of these entries in detail when we will do the detailed continent by continent basis atlas. So each class I will be using one separate continent. It might happen that a continent called as Africa will take 2 lectures. A continent called as North America will take 3 lectures. Europe can take 3 to even 4 lectures. India, my God, will take roughly 4 to 5 lectures. So don't worry with regards to that. I'm here with you. Just plain blindly trust me. So we will move step by step with everyone. Okay. So I'm opening the world's Pandora box. I'm opening up the world atlas for you all now for discussing some of the mountain ranges. Okay. So I'm taking you back to the discussion of the Hercynian and Caledonian mountain building phase. Okay. So the world's oldest mountain ranges after the Vindhyas, Satpuras, and after the Eastern Ghats. So Eastern Ghats are the world's oldest. Then you have Vindhyas, you have Satpuras. After that, you have a mountain range in Scandinavian Peninsula. So if I take you to Scandinavian Peninsula over here, Scandinavian Peninsula is basically this part. Okay, this part of the world, this is called as Scandinavian Peninsula. Okay, this is called as Scandinavian Peninsula. Okay, so you have countries like Sweden, Norway, Denmark, Finland. So you have the countries like Sweden, Norway, Denmark, and Finland. And if you see this white part, the snow-capped mountains over here. Okay, if you see this white part, the snow-capped mountains over here, these are some of the world's oldest mountain ranges. They are called as Kejolin Mountains. They are called as what? They are called as Kejolin Mountains. Okay, so one of the world's first mountain ranges after the Eastern Ghats, Vindhyas, and Satpuras. So this, where you find this in the Scandinavian Peninsula. Okay. Apart from that, you have the same orogeny in UK. This is the United Kingdom. This small islands you have, this is UK, and this is the island of Ireland. So in the north again you will see this mountainous territory. This is called as Scottish Highlands. This is called as Scottish Highlands. This is called as Scottish Highlands. So Scottish Highlands and Kejolin Mountains of the Scandinavian Peninsula, they together make up one of the world's oldest mountain building phase, and they have uplifted once the Rodinia break up and the individual pieces, it again starts to collide. Okay. So after this, we have the Hercynian mountain building phase. So now let us move and towards understanding the Hercynian mountain building phase. In the Hercynian mountain building phase, just excuse me a moment. Yeah. So let's continue. See, Hercynian mountain building phase. After this Caledonian mountain building phase, you have the Hercynian mountain building phase. In Hercynian mountain building phase, you have 3 to 5 distinct entries. Which entries you have in the Hercynian mountain building phase? So now let's discuss. Okay, so these are our Scottish Highlands. I'm zooming out of it now. I'm clearing the board for you all. Okay. So the first entry that I'm discussing in the Hercynian mountain building phase is the entry called as in USA, you have in this part of the world, this part, if you can see, okay, this is North America. So if I'm zooming on this part of the world, this is where you will have the first of the Hercynian mountains. Okay, so this part of America, you can have the states like Philadelphia, you have states like Virginia, you have states like North Carolina, South Carolina, you have New York, okay, you have Delaware. So you have one mountain range over here called as Appalachians. called as Appalachians. So Appalachians are some of the world's oldest mountains. They belong to the Hercynian mountain building phase. After Vindhyas, after Satpuras, after Eastern Ghats, you have the Caledonian mountain building phase. Caledonian mountain building phase is where you have the Kejolan mountains, where you have the Scottish highlands. After that, you have the Hercynian mountain building phase, where you have upliftment of Appalachians in North America. So please remember this entry, guys. This is extremely important. Okay. Apart with Appalachians, you also have a mountains called as the Urals in Russia. Okay. So if I'm showcasing you the Urals of Russia, so for again I'm bringing you to the continent of Europe. Okay. So if I zoom in over here, okay. So if you can see these mountains, so Urals basically separate the Siberian part of Russia from the continental Europe. So these are our Urals. These are our Ural mountains. So Urals are basically those mountains that separate the continental part of Europe from rest of the Asia. So separating Eurasia from Europe. So you have Appalachians, you have the Urals of Russia. Okay, one of the oldest mountain ranges of the world called as the Hercynian mountains. After Urals, you have one mountain range in UK. Okay, in UK, in the middle of UK, where you have the cradle of industrial civilization, of industrial revolution, in the middle of island of UK over here, you have one mountain range called as Pennines. You have a mountain range called as Pennines of UK, right in the middle. So you have Appalachians of North America, you have Pennines of UK, you have Urals of Russia, and in the same time scale, you also have the orogeny of the Atlas Mountains of Africa. You also have the orogeny of the Atlas Mountains of Africa. So if you see this part, okay, this part of Africa is where you have the Atlas Mountains. Okay, the Atlas Mountains. So Atlas Mountains and the Appalachian Mountains, both of them have uplifted together roughly 200 million years ago. Okay, so you have the Hercynian Mountains. And the last mountain range of this, we have to divert our attention towards Australia now. So now let's move towards Australia. So if I'm opening up Australia for you all, okay. So if you see the east coast of Australia, this complete east coast of Australia, this complete one mountain range, this is called as GDR. The full form is Great Dividing Range. You have the Great Dividing Range of Australia, this entire eastern part. Okay, so if I'm summarizing the Caledonian Mountains and the Hercynian Mountains for you all, I will quickly revise it everything again. So first of all, I'm writing down the names for you so that you can take those entries down. So Caledonian Mountains, you have two things. You have two distinct entries of Caledonian Mountains. So first mountain building phase, it is called as the Caledonian mountain building phase. Mountain building phase. Okay, this is after what? After Rodinia breaks up, after the individual pieces they start to combine, they start to basically interact with one another, and you have upliftment of the mountains. So the Caledonian mountain building phase will give you mountains like the Kejolan mountains, and you will have the Scottish Highlands, and you will have the Scottish Highlands. Scottish Highlands. Okay, so Caledonian Mountains. After this mountain building phase, you will have the Hercynian mountain building phase. You will have the Hercynian mountain building phase. Hercynian mountain building phase. In this mountain building phase, you will have upliftment of the Appalachians. You will have the upliftment of the Appalachians. Okay, you will have upliftment of the Urals of Russia. You will have the upliftment of the Pennines of Britain. Pennines. You will have the upliftment of the, okay, sorry, my bad. You will have the upliftment of the Pennines. Pennines of Britain. So Appalachians you will have in USA. Urals you will have in Russia. Pennines you will have in UK, and you will have GDR of Australia. Okay, and when the Appalachians are uplifting, you will also have the Atlas Mountains. You will also have the Atlas Mountains of Africa. Okay, so these are some of the important mountain building phases after the breaking up of Rhodia and the upliftment of the mountains. So if I am basically showcasing this you all again on the world map, so again I am taking you to the world tour. We will mark these locations on the world map. Guys, today is just introduction. Don't get frightened. Vishal, I have Utnang, I also have Rahul. If you are listening to me, you are free to comment too. Please don't get frightened as of now. Why? Because today I'm just introducing. I have not yet started the detailed discussions of maps. Each one of this entry will be very easy for you to get once we have done all this. So please treat this as a precursor. Okay. So it's basically we are building the base, and on the base we will build up the giant pyramid. So please trust me, have faith in me. You and me will both sell together. I am not a faculty which will cringe in as much information as possible. I am also evolving with you. You will also evolve with me. Okay, so big smile on our faces. Again, we are opening up the world's Pandora box. We are opening up the world atlas, where I'm again showcasing you all these ranges very properly. Okay. So now I'm using the complete world atlas for showcasing you all the ranges, and for this I will be using the 3D map of Earth. Okay, I won't be using the 2D map, so that you get working understanding of all the locations. So let's begin. Okay, so the first mountain range that I'm discussing with you all will be in North America. Okay, the first, or let's begin with the Caledonian mountain building phase. Let us move first towards Scandinavia. In Scandinavia over here, this entry that you are seeing, this white entry, this is called as Kjollen. This is called as Kjollen Mountains. Here you have Scottish Highlands. Here you have Scottish Highlands. Okay, here you have Scottish Highlands. Okay, both of them are Caledonian Mountains. Both of them are Caledonian Mountains. Okay, so they belong to the Caledonian mountain building phase. So please get this very properly. So you have the Scottish Highlands and you have the Kjollen Mountains. Both of them are a part of the Caledonian mountain building phase. After this, we are shifting our attention towards North America. We are now discussing the mountain ranges of the Hercynian era, of the Hercynian mountain building phase. So in North America, you have the Appalachians. Over here, you have the Appalachians. Appalachians. The Appalachians of USA. You have Appalachian Mountains, you have Allegheny Mountains, you have Blue Ridge Mountains. So these are some of the local mountains in the Appalachian mountain range. Entire Appalachians are very crystalline. And guys, you get some of the world's best marble over here. So you must have heard the Italian marble. So the marble which comes from Appalachian, it is even more pristine. Why? Considering the age of these mountains. So in Appalachians, you do have a mountain range called as Blue Ridge. Okay, we will do this when we'll do the detailed physical map of North America. In the Blue Ridge Mountain, you have the world's most beautiful marble, and you also have one of the world's most beautiful granitic stones you can have. Hence, you see the big mansions that you have in North America, they are so damn beautiful. Why? Because of geography. Okay. And of course, they have money too. Okay. So, jokes apart. So, you have Appalachians. Okay. After Appalachians, if I move ahead with the discussion, you have the Urals of Russia. So, this part of the world over here, you have the Urals. So, this is the Urals of Russia. Okay, Urals of Russia. Okay, Urals basically they separate the continental Europe from the Asia, from the Eurasia. So here you have Europe, here you have Eurasia. Okay, okay, okay. So Eurasia in the sense that it separates basically the Russian part of Europe from the Asia. So to the east of Urals, you will predominantly have Russia. You will east of Urals, you will predominantly have Asia. Okay, so separating Europe and Asia for our own reference. Okay, after this, let's move towards the discussion of Australia. So if you go to Australia and if we zoom in, okay, so this is where you have the GDR of Australia. GDR, the Great Dividing Range of Australia. Okay, the Great Dividing Range of Australia. Okay, so this is done, and then the last entry you can have with the origin of the Appalachians, with the orogeny with regards to Appalachians. So the time scale when Appalachians were formed, you also have the origin of Atlas Mountains of Africa. You also have the Atlas Mountains of Africa. Okay, guys, the world which you see today was not the same which you had prior. Okay, first you had a very big supercontinent called as Rodinia. Rodinia will start to break up. The individual pieces will start to collide with one another. You will have upliftment of mountain ranges, forming the Caledonian Mountains, forming the Hercynian Mountains. So all of these continents were fused together. They were fused, they got separated, and they again got fused. So after Hercynian and Caledonian Mountain building phase, you have the formation of another big supercontinent which someone pointed out, Utnang pointed out, the formation of the world's recent supercontinent called as Pangaea. So after the Hercynian mountain building phase, you have the formation of another supercontinent called as Pangaea. Okay, so after the Hercynian mountain building phase, okay, after both of this, you have formation of another supercontinent called as Pangaea. Okay, the Pangaea will again break up. As the Pangaea will break up, you will have the most recent mountain building phase called as the tertiary alpine mountain building phase. You will have the most recent mountain building phase called as the tertiary alpine mountain building phase. So we will stop our discussion over here because the tertiary alpine mountain building phase will take some of little time to get discussed. So basically, I'm quickly revising what I covered with you all today. So the nebular accretion process basically resulted into the heaviest of core and the lightest of the outer layers of Earth. So because of this, you have density based stratification on Earth. So the world's first crust or the world's primitive crust was nothing what we have today. It was very fragile. It was very corrugated with ridges. So you can consider it to be the cream layer which forms atop the kettle of boiling milk pot. So it was bombarded with outside celestial bodies because you didn't have any atmosphere to. Okay. So you have the formation of the world's first supercontinent called as Rodinia. You have upliftment of the eastern Ghats of India. You have the upliftment of Satpuras and Vindhyas. Both of all three of this, they are very old mountain ranges, more than 2.7, 2.8 billion years. Okay. After that, you have two distinct mountain building phases. You have Caledonian mountain building phase and you have the Hercynian mountain building phase. The names of Caledonian mountains, you have Kejolan mountains, you have the Scottish Highlands. I know majority of you must have seen Harry Potter, the movie. So where you have the Hogwarts castle, so that is where you have the Scottish Highlands. So whenever now you will see Harry Potter, you should think of me that yes, I have taught you the Caledonian mountains. Then you have the Hercynian mountains, you have Appalachians of USA, you have Pennines of Britain, you have Urals of Russia, you have GDR of Australia, and simultaneously with Appalachians, you have orogeny of Atlas Mountains of Africa too. After these two mountain building phases, you have formation of the next big supercontinent, that is Pangaea. The Pangaea will break up. The breakup of Pangaea will be into two. You will have Laurentia and you will have Gondwana land. Okay, so these two pieces will break up, the continents will finally break up, and when the continents again start to collide, you have formation of the third phase of mountain building, that is called as tertiary alpine mountain building phase. So the continental structure that you see today, you have North America, you have South America, you have Europe, you have Africa, you have Asia, you have Australia and New Zealand. So the structure which you see today, it is basically the breakup of Pangaea, and the continents are still colliding. Okay, tomorrow it will be a very fascinating class, because from tomorrow we will see that how continents have finally broke up and what is the present day structure. So tomorrow you will be spellbound by the geological history of Earth, so prepare to be amazed. Okay, so I am ending my note on a very astonishing fact for each and every one of you. Those of you who are watching me live, or those of you who will watch me in a later time. Okay, you know guys, Earth is a planet which has formed from the giant amorphous cloud of hydrogen and helium. Okay, on Earth you have heavier elements like iron, copper, zirconium, zinc, even heavier elements like uranium, thorium. You think guys that Earth had so much of energy that it can fuse such big elements? No, it's not possible that only Big Bang, it's not possible that only this nebular accretion can result into fusion of such big elements on Earth. Okay, even on Sun, what is happening? Two hydrogen atoms are forming one helium atom. It is nuclear fusion. So do you think that Earth has so much of energy to form such big elements? Of course not. So what does this mean, guys? That all of the heavier elements that you have on Earth, they are basically come from the outside celestial dust. So somewhere two stars have died, somewhere a galaxy has exploded, somewhere a star has exploded. From there you have this cosmic dust which has been thrown on Earth, and whatever I'm speaking is reaching your ears. You are seeing this board through your eyes, you are getting this information, and the bodily function is maintained by hemoglobin. How? Because hemoglobin is transporting oxygen in your body from your brain to your toes, from your heart to every part, and hemoglobin will have predominantly iron. Okay, so it said you should have high iron content foods. Why? Because your hemoglobin will be maintained. So you think guys, the hemoglobin in your body has come from where? The hemoglobin in your body has come from the outside cosmic dust. So somewhere in the distant galaxies, a star has burst. Somewhere in the distant universe, two bodies have collided, two black holes have collided, two neutron stars have collided. From there, the cosmic dust has come on Earth. and the hemoglobin in your right hand versus the hemoglobin in your left hand, the blood in your left leg versus the blood in your left leg can have iron coming from two distinct stars. So it might happen that in your right hand, the iron which you are having has come from one planet, one star. In your left hand, the hemoglobin which you have has come from different galaxy. So guys, you owe your origin to the universe. Please get this point very, very properly. I don't know how many of you will watch these lectures, how many of you will actually get this point, but you owe your origin to the universe. That's the most astonishing fact. It's not possible to have heavier elements like iron, zinc, magnesium in your body from just the earth. Somewhere in the universe, a star has exploded. Somewhere in the universe, a galaxy has exploded. From there, the cosmic dust has come, resulting into your birth on earth. So now, whenever you will look up in the sky, always bow down to the universe because you owe your origin to the universe. So I end my note, I end my lecture on this part. I hope that this lecture was of utilitarian value for each and every one of you. I'm again quickly introducing myself. So my name is Pritesh Maturkar. You can reach out to me on Telegram via a channel called as Geography by Pritesh Maturkar. For doing this, you can just do a global search at Geography by Pritesh so that you come in contact with me and we share the relevant information. Okay. So on this note, I sign off for today, guys. Tomorrow we'll meet for lecture number 15 and prepare to be spellbound tomorrow because we will see the breakup of Earth, we'll see the formation of Pangea, breakup of Pangea, and then there the present status of the Earth's continental layers. So thank you on the behalf of StudyIQ IAS English. All the best everyone. Keep on working hard and smart. See you all tomorrow sharp at 5 p.m. Take care everyone.